Hello everyone, welcome back to For Loops Basics Part 2. In our previous video, we covered the fundamentals of for loops with ranges and steps. Today we are going to explore more advanced for loop concepts that will give you greater control over your loops. Let's get started. In Part 1, we learned how to use for loops with different start and end values, custom steps, and even counting backwards. Now we are building on that foundation. In today's video, we'll cover 4 essential concepts. First, nested for loops, loops placed inside other loops for creating patterns and grids. Second, the break statement, which let us exit a loop early. Third, the continue statement, for skipping specific iterations. And fourth, loop variable scope, understanding where our loop variable can be used. These tools will take your loop control skills to the next level.
Let's begin with nested loops. Simply put, a nested loop is a for loop inside another for loop. Here's the key concept. The outer loop runs once, and during that single iteration, the inner loop completes all of its iterations. Then, the outer loop runs a second time, and again, the inner loop goes through all its iterations from start to finish. Imagine you're organizing books on shelves. The outer loop represents each shelf and the inner loop represents each book on the shelf. You place all books on the shelf 1, then move to shelf 2 and place all the books there, and so on. So, nested loops are incredibly powerful for creating patterns like stars or numbers, working with rows and columns, or processing two-dimensional structures. Next, let's talk about the break statement. Sometimes you need to exit a loop before it completes all its planned iterations. When the program hits a break statement, it immediately terminates the loop and continues with the code after the loop. Think of it as an emergency exit. A practical example would be imagining searching through a list of 100 numbers to find a specific value. Once you find it, there is no point in checking the remaining numbers. You can use break to exit immediately, making your program faster and more efficient. The continue statement works differently from break. Instead of exiting the entire loop, continue just skips the rest of the current iteration and jumps straight to the next one. It's like a selective filter. When a certain condition is met, you say skip this one and move to the next cycle. The loop keeps running, but you've skipped processing that particular value. For example, if you want to print all numbers from 1 to 20 except even numbers, you would use continue to skip the even ones while still processing all the odd numbers. Finally, let's understand loop variable scope. In our previous video, we used variables like I in our for loops. But where can these variables actually be used? The answer is only inside the loop. Once the loop ends, the variable no longer exists. It's gone. You cannot access it outside the loop. This might seem limiting, but it's actually a feature, not a bug. It prevents your loop variables from interfering with other parts of your code and keeps everything organized and conflict-free. Now let's combine all 4 concepts in one comprehensive program. Now here in line 1 and 2, you can see our standard setup where we include our stdio library and our main function. And here our first concept, nested loops. Notice we have 2 for loops, one inside the other. The outer loop uses the variable row and runs 3 times. For each value of row, the inner loop with variable col runs completely 4 times. We multiply row times columns to create a multiplication pattern. After each complete inner loop, we print a new line to move to the next row. This creates a 3x4 grid of numbers. Now let's break the next lines of code. We are searching for the first number between 1 and 30 that's divisible by 8. For each number, we check if it's divisible by 8. If it's not, we print that it's not divisible and continue. When we reach 8, the condition becomes true. We print found it and break statement immediately terminates the loop. We never check 9 through 30 because we've already exited. Now for loops with continue. So this shows the continue statement. We want to print only even numbers from 1 to 12. For each number, we check if it's odd by seeing if the remainder when divided by 2 is not 0. So if the number is odd, continue skips the rest of the iteration specifically. It skips the printf statement below. So odd numbers are never printed. So when the number is even, we reach the printf and display it. Now, scope demonstration. Inside the for loop, we declare and use a variable called counter. We can print it, use it in calculations, do whatever we want with it, but only inside the loop. So after line 42, when the loop ends, the variable counter disappears. The comment reminds us that trying to use counter outside the loop would result in an error. So then we return 0, indicating our program is completed successfully, and we try running this code. So here we can see the result, our nested loop example, which shows a 3 into 4 grid of multiplication pattern. Then our break statement example, where we can see we are trying to find the first multiple of 8 between 1 to 30, and once it is found, the break statement terminates the loop. Then we have our continue statement, which is trying to find even numbers from 1 to 12, and our variable scope example, which shows our loop iterations and our counters. And loop finished, variable counter is no longer accessible, is shown because it is not accessible outside of the loop.
Now it's your turn to practice. Head over to CodeChef and try creating your own nested loops. Experiment with break and continue statements and test variable scope. Challenge yourself to create different patterns and solve problems using these techniques. Keep practicing, and I'll see you in the next video. Happy coding!